seems to be. Okay, lesson 96. The difference between f of the absolute value of x versus the absolute value of f of x. All right, now what I tend to call this, I call this the absolute value of y. So when you're thinking about the absolute value of the function, you're thinking about the absolute value of y. This is different. This is f of the absolute value of x. Means instead of putting in -3, you put in 3. Okay? And so we're going to be talking about the difference between f of the absolute value of x and the absolute value of f of x as far as the derivatives of those, of what I call the absolute value of x, and this one I call the absolute value of y, versus the integral of those, again, the absolute value of x versus the absolute value of y. Alright, so first of all, I'm going to start with the absolute value of f of x. Again, I think of this as the absolute value of y. Alright, so here's my purple function. If I can find my purple. That one's closed. Alright, so here's my purple function. And at point A, this is my slope. And at point B, this is my slope. Well, if I'm asked to take the absolute value of that function, the absolute value of that function, well, if the y value is positive, that doesn't change, right? But what happens right here? Where the y value here becomes negative, well, it just flips around and becomes positive, right? So it looks sort of like this. It's not exact. All right, so but let's look here at point A. At point A, my slope is exactly the same, right? Well, that's not a very good tangent, but my slope is exactly the same. So when the y value, when your f of x is greater than 0, then the slope is the same. The slope is just f prime of x, right? But what about when y is less than 0? Look over here at point B. At point B, this was this slope. If I come here, it's this way. Now the change in y, change in x is very similar, but it's just the negative f prime of x. This one's positive, right? Well, it's the same, it's a negative slope. This one went from being positive to being negative, so it's the opposite slope, but it's the same value. What about when y equals 0? What about here? About when y equals 0, what's my slope? My slope does not exist because that's what we call a corner. That's a corner, a sharp point. A cusp is another thing you'll see it referred to as a cusp. It's not differentiable there. Alright, so mathematically, I look at the picture and I figure it out. Okay, mathematically, it's written like this. Mathematically, you take f of x divided by the absolute value of f of x, and what does that equal? Well, up here, if f of x was greater than 0, okay, so if the y value was greater than 0, that's right here, that's this section. Well, what does f of x divided by the absolute value of f of x equal? It equals 1, right? So that equals, whoops, blue. That equals 1. So if this is, if f of x is greater than 0, that equals 1. Well, what if f of x is less than 0? So it would be if it's less than 0, this would be a negative value divided by the absolute value of that would be positive, so that's going to equal -1. Well, what about if f of x equals 0? Then this does not exist. Does that look familiar? If f of x is greater than 0, it equals 1. It's the same. If f of x is less than 0, it's negative times the original. And if f of x equals 0, it does not exist. So this is kind of a scary, to me, looking math phrase, but that's all it's telling me. So let's look at an example. This one I think is e to the x. Okay. No, this is sine x. Alright, so the derivative of the absolute value of sine x. Remember, we're taking the derivative of the absolute value of the y. So the absolute value of the y means you take f of x divided by the absolute value of f of x times the derivative of that. That looks scary. It's not. So this is simply sine x divided by the absolute value of sine x times the derivative of the sine is the cosine x. What does this mean? this means if sine is positive, it just takes the cosine function and makes it positive, right? It just looks like this. Here's my cosine function, and instead of becoming negative, it just turns positive. It's either 1 or negative 1, 1 or negative 1, depending. So it looks scary, but it's not. It's just, so this is what, pi over 2, no, that's right, yeah, 0, yeah, that's right, pi over 2, pi, 3 pi over 2, and 2 pi. It just takes the cosine function and makes it positive. It looks kind of scary, but it's not. All right, another example. Oh, yeah, this is just the absolute value of x. So if we're asked, this shows that the absolute value of f of x is simply the absolute value of y. So if this were the function x squared minus 4, then let's see here, x squared minus 4, this would be negative 2, and this would be 2, and this would be a negative 4 y value, right? So x equals negative 2, my function is a y value of 0, a y value. And if my function is 2, the y value is 0. If x is 0, the y value is negative 4. Now if I take the absolute value of that, it takes everything that's negative and makes it positive. All right, so the slope here is negative, but if I found the slope there and went the absolute value, the slope there would be positive. Here's the slope remains the same. Right here, the slope is always the same. It's in this area where f of x is normally negative, the slope becomes the opposite of what it is. All right. Now, on to the absolute value of f of the absolute value of x. All right, so this is different. When I take f of the absolute value of x, this causes the function to be even. What does that mean? So f of negative 3. Well, if I take f of the absolute value of negative 3, that would simply be f of 3. That's this value, right? F of negative 1 would be here, but f of the absolute value of negative 1, f of 1, that would be this value. So what happens is my function when x is greater than 0 remains the same. I'm going to try to draw it about the same, all right? When f is less than 0, when x is less than 0, all it does is mimic. It just mimics that and becomes an even function. How does that help us? If I need to take the integral from negative k to k, I recognize that that's 2 times the integral 0 to k. All right. I think that's about it with that one. So let's look at an example. We work these by making them piece functions. All right. We work these by making them piece functions. Let's see here. All right. To find f prime of the absolute value of x, I keep doing that. That should be a vertical. Of the absolute value of x, make it a piece function. All right, so f of x equals e raised to the absolute value of x. So what's that tell me? Well, if x is greater than or equal to 0, f of x is just e to the x. If x is less than 0, then instead of negative 1, I have to put in 1, so I put the negative sign in here. So it becomes e to the x if x is greater than or equal to 0, and e to the negative x if x is less than 0. So what's the derivative of that? What's the derivative of this? Derivative of e to the x is e to the x. Derivative of e to the negative x is negative e to the negative x. Now, is this function continuous? How do I decide that? I take the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right of f of x. All right, so that's this guy. All right, as I approach 0 from the left, a little bit less, e to the negative 0 is 1, right? As I approach 0 from the right, e to the to positive 0 is also 1. So yes, it is continuous. But is it differentiable? How do I decide if it's differentiable? Now I take the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right, not of f of x, but of f prime. That's this one. Well, as x approaches 0 from the left, a little bit less than 0, so that's this guy right here, a little bit less than 0, this is negative 1. And as I approach 0 from the right, a little bit more than 0, anything 0 power is 1. Does negative 1 equal 1? No, it does not. So the function is continuous, but it's not differentiable. And I believe your textbook probably has a picture of that to show why that is. All right, let's look at example 96.2. Example 96.2 tells us that f of x is the cosine of the absolute value of 2x. So we need, right, this is not the absolute value of y. This is not the absolute value of y. This one's the absolute value of x. So it's going to become an even function. We don't care what the negatives do. All right, so we're going to break it into pieces. Let's see. So if x is less than or equal to 0, x is greater than 0, f of x is cosine of 2x. If I'm less than 0, I take the opposite, negative 2x. But wait, cosine. Something special about cosine and negative. Let me come up here and make a quick picture. All right, this is positive theta. This is negative theta. The cosine is the x value. What do you see here? The cosine of a negative angle is equal to the cosine of a positive angle. So this doesn't make any difference. This is still cosine 2x. It doesn't matter if it's positive or negative. So this function is unique in that it doesn't matter. So then what's the derivative? So let's look at the derivative. See, f prime. Derivative of the cosine is negative sine of 2x, but don't forget the chain rule, so times 2. So negative 2 sine 2x, and this one is also negative 2 sine 2x because it's the same function. So this one is both continuous and differentiable. Okay, let's look at example 96.3. Okay, 96.3 asks us to find the integral from negative 3 to 3 absolute value of x plus 1. Now wait, am I finding is this an make x positive? Is this an absolute value of x? Or is this an absolute value of y? All right, you're correct. It's the absolute value of y. So what's that mean? It means I'm going to take this x plus 1. Let's see here. If x is 0, it's 1. If x is negative 1, it's 0. It's a slope with a line of 1. So I'm going to take this function at x plus 1 and I'm going to make it positive. What's that mean? That means everywhere this is negative, this becomes positive, right? So this no longer exists. So it's going to be the absolute value of x plus 1. Looks like this. So it has a corner or a cusp at negative 1, right? That would be the point negative 1. Oops, I'm still in my eraser. So this would be the point negative 1. Right here, negative 1. Well, we're asked to take the integral from negative 3 to 3. Negative 3 to probably over here, 1, 2, 3 to 3. So what is that? That's just two triangles. Right? So I'm looking for this total area. Now if I were putting it in my calculator, which I know some of you prefer, you would be taking the opposite of negative 3 to 1 of x plus 1 dx, right? Because instead of this down here, which has a negative value, a negative area in the curve, you're putting a negative sign in front of it to make it positive, plus the positive, it's above the curve, negative 1 to 3, x plus 1 dx, and I believe this is a 4 by 4 triangle, so that's as an 8, and this is a 2 by 2, so that makes this one a 2, so that makes a total of 10. Alright, you calculator nerds. There's also a an ability to take negative, whoops, this should be -1 to 3. -3 to 3, absolute value, x plus 1 dx, and that also would equal 10. But be very careful doing this, because the reason I'm telling you this is not because I want you to use it, because I want you to not use it when it doesn't apply. This applies because this is a continuous function. If something were to happen in here with this switching and it were not a continuous function, this would not work. You cannot take the integral of a function that's not continuous. This work, you can put the absolute value symbol in your calculator and get it to tell you 10, but only if your function's continuous. So don't skip that step. There's thinking involved instead of just plugging in numbers. All right, last example. All right, there's 2 more examples, 2 more on your owns in your textbook. Please read through, or not on your owns, examples in your textbook. Read through those, keeping in mind the difference between absolute value of y and absolute value of x. Okay, example 96.7, though, I did want to go ahead and go over with you because it's one of those thinking problems, not necessarily my strong suit. Okay, thinking. All right, given, there's no picture involved is my problem. All right, given f of x is continuous, all right, so that's important. We know the absolute value of f of x, maximum value, is 6, and the absolute minimum value is -12. Somebody's theorem tells us somewhere in there my function also has at least one value of 0, right? Because I can't get from a value of 6 to a value of -12 and be a continuous function without at least one time passing 0, right? At least one time passing 0. Now notice I put -12 here and 6 there. It doesn't tell me that that's the case. It could also be the case that -12, whoops, is here and 6 is here, right? I mean, so there's no reason that it has to only cross once. It could cross 3 or 4 times and do all kinds of crazy stuff, right? But I know it has a maximum of 6. Whoops, I gotta turn around there someplace and come down here. And a minimum of -12, not to scale. All right, so that's all I know. Now let's look at the question. Which of the following must be true? The maximum value of the absolute value of f of x plus 1 equals 6. Is that true? Well, wait. Absolute value of f of x plus 1. So, okay, so this is if the y, if I'm making the y's positive. What about this x plus 1 do? That just takes the whole function and shifts it 1 left. Right, so just take the whole function and shift it 1 left, right? Subtract the shift, so minus a -1. So the whole function has shifted 1 left. Now I'm going to take all the y values and make them positive. So it doesn't matter whether 6 is to the left or 6 is to the right. If I take all these y values and make them positive, it's going to come up here, right? This is going to come up here to a value of 12, and this one will come up here to a value of 12. So that's not correct. So when I shift it 1 left and make all my y values positive, my maximum value is 12. All right. So let's look at this one. The minimum value of f of the absolute value of x equals 0. Wait a second. Now if it was asking me the minimum value of the absolute value of f of x is 0, yes, because remember we talked about it has to cross at least once. If I'm making all the y values positive, right, that's going to stay there. But what about this? This doesn't say that. This says the x values. Well, so the minimum value of f of x, f of the absolute value of x, well, if I make the x's, absolute value of the x's, all I'm doing is mimicking, right? Remember, everything where x is negative no longer exists, and I have to mimic it this way on this side. Give me a pen. This way on this, I know I pushed that, this way on this side like this, right? So that doesn't make any sense, right? Or the same thing here. If it was this way, I would just erase all these and mimic it to this side, just copy it so it looked like that, right? So that will have a minimum value much less than 0. All right. Actually, we don't know what the minimum value of that one is. It could be -12 or it could be something less. All right, so that one's out. So that one's not true and that one's not true. What about this one? The maximum value of the absolute value of f of x. But when I make the y values positive, that is going to flip up here and give a maximum value of 12. So that one is the only one that must be true. Okay, enjoy your spring break.